What is up? Daniel here with the Virtual Robotics Studio. We're back for the second Swerve video. You should have 4 fully assembled Swerve modules. Our goal is now going to be to use some of this 2x1 aluminum box to connect up the sides and give us the outline sort of our chassis. But before we get started building, we have to give a special thanks to Argosy for making this all possible, as well as our product sponsors, West Coast Products and Cross the Road Electronics. And also a thanks to Team 302 and Lake Orion High School for hosting our studio. All right, so in the last video, we talked a little bit about using this box material and how it was going to fit in between our 2 plates here. And there are actually bolt holes that line up that are going to be good to go with that. And the idea is we'll then have this one connected on this side, have another one connected all the way on the other side, and that is the outline of the robot. That actually will be pretty sturdy and held together. There's a couple things that we have to do, though. Is first you have to decide what size robot you want, because that's going to determine how much we have to cut this bar down. Now, of course, you need to check the rules of the competition for that year. What's the perimeter size? What does your design say? How big or how small do you want it to be? Cool part is it's pretty easy to change the size of the robot until you add the belly pan or other parts to it. So these, you just cut down to whatever size you want. These are 2x1 aluminum. It's 0.1 wall thickness. And then from West Coast Products, it comes like with all the holes already assembled. That's actually great. It saves a lot of time aligning this, but you could probably get a cheaper piece of aluminum without the holes if you wanted to and drill them yourself. Okay, so I'm going to try to make this robot 28 inches by 28 inches because I like square robots. Generally speaking, for Swerve, the closer you are to square, the kind of better everything is going to be. It will work if you're way out of square, but just because of the way the robot rotates, it's nice to sort of have something that's relatively even in dimensions. Now that said, when we go to do the code and we go to do the generator to create the code, it will compensate for that. So it will know what size your robot is, and it will make adjustments to the wheel angles so that you can spin in place and things like that. Now, if we measure the module, and kind of what we're looking for is the end of the module to the farthest out hole, because that's going to dictate sort of what size our stuff is. So if I measure in from the edge of the module to our first set of holes here, our first hole in this set of holes, it's about 4.5 inches off the edge. It's actually probably exactly 4.5 inches off the edge. All right, so what that means is whatever size we want our robot to be, we're going to have 4.5 inches on this corner, 4.5 inches on this corner. So if I want a 28-inch robot, I've got 4.5 and 4.5, so that's 9. So I actually need 19 inches hole to hole. So if I take a look at this piece, at our metal here, I need to create a 19-inch hole-to-hole piece. So I guess if I start off the end here, and I measure in, it's not 19. That's not what I'm looking for. The first hole is a 1/2 inch in. So if I go to 19.5, this hole is the last hole that I want to use. But obviously, I can't cut it right at the hole because I need some material past it. So what I'm looking for then is, and I'm just going to sort of mark, this is the last hole I'm going to use here. So we're going to cut it somewhere in between here. And ideally, we want to be exactly halfway in between those 2 holes. Obviously, it's not going to be that big of a deal if we just measure out to 19 3/4 and mark that line to be able to cut. But I can be a little bit more accurate. So if I get some calipers, sort of like the minimum distance between the 2, let's see, it's 0.3. So if I cut that in half to 0.15, then I can sort of scribe a little bit there and scribe a little bit here. And yeah, that lines up. So that line is where I'm aiming to make my cut. And depending on what saw you're going to use to make your cuts, you could potentially need to draw that line all the way across. So you can do that, right? You can transfer that line either with a scribe or a marker. I'm going to cut with a metal chop saw. So for me, even just a little mark is going to be enough for me to line stuff up. Okay, so that is our first cut. We're going to make 4 total cuts, or four total pieces. We can fit 2 on each stick. These are, is that 4 feet tall? Yeah, 47 inches. So, and I think you can buy different sizes of lengths of this depending on, shipping prices and stuff like that. So you just got to kind of figure out what works for you. I can just sort of match the first one. And again, because the holes are the important part, if I cut this a little bit too long or a little bit too short, like if I'm not perfectly in the center, it doesn't really matter as long as there's enough material around the holes on either side that I can use the piece that is left over. All right, there's one more thing I'm going to show you before we go over to the saw, and that is, let me go ahead and actually attach one of these onto a module temporarily. So for this, we have a bunch of leftover 2.5-inch long bolts. Those are what we're going to use to hold everything together. And the top holes are tapped. So we actually are going to bring these in from the bottom when we do this. So I've got it flipped over, the wheel's in the air. If I bring this piece in and line it up so that the first hole on the aluminum lines up with the farthest hole in on the frame here, we should be able to get the bolts to just drop in nicely if everything is lined up. There we go. And I don't even need to screw these in a lot. I just need to get them started enough to show you what our issue is here. All right, that looks good. All right, so this is held where it's going to be. Obviously, it's not tight. Don't worry about that. But what we want to look at now is the wheel. So we can see the wheel, and you can see there is a corner of aluminum right there sticking in. And one of the problems is this wheel is hitting that corner. All right, so we can't leave this uncut edge sticking out quite as far as it is. So let me undo these bolts. Oh, gonna need an Allen wrench for that one. So basically what this means is that we have the factory edge. Normally when you're building stuff, right, you like the factory edge because it's usually pretty clean and easy to build off of. But in this case, we can't leave it because it's going to hit stuff. So we're going to mark the other side as well. And we're going to look to take off about 1/4 of an inch. So it was 1/2 inch to the edge of the piece, to the center of the hole. And we're going to make it be 1/4 of an inch instead. So we can see like the gap in total, right? That was that point, well, in this case, it's 0.4. So we're going to take about 1/4 of an inch off or 0.2 off. And you can just scribe that along the outside edge. And you can see once you do that, actually I'll take a whole 1/4 inch off, 0.25. You can see if it looks like, it's getting too close to the hole to where you're going to get scared. For me, I think that's totally fine. That's at least as much as we're going to have on the other side after we make our saw cut. So, we're happy with that, and that is going to leave us with enough clearance for the wheel to spin. Now, if we do this and it still hits, you could take the corner that's hitting the wheel to the grinder and 45 that corner. In fact, we don't have to make this cut. You could just do a diagonal cut here instead, because it really is just the one corner that's hitting. But for a lot of people, it's easy to make just the straight cut all the way across. So whatever way you want to do it, we're going to mark this one too the same way so that we can go ahead and cut both of these at the same time. So 1/4 of an inch on this one as well. All right, so that's good. We're going to go ahead and take these over to the saw, make a couple cuts. We'll come back, mark our other two, and then back to the saw. Okay, of course, use whatever saw you have available to you to make cuts. I've got a metal cutting chop saw here, so I'm going to use that. That I find is the best to make clean vertical cuts through stuff. Obviously, we got the little tabletop bandsaw. You could use that as well. But you probably would have to do a first cut with a hacksaw in the middle. That's the downside to those. Anyway, let's line this up. First cut I'm going to do is that little bit, that 1/4 inch that we wanted to take off the edge. Looks pretty good. Make sure it's flat, clamp it in, and here we go. And then to our line. And since I want to use both sides of this, I'm going to try to just be centered on the line right in between the two sets of holes. Looks good. All right, one piece is good. Same thing on our other section here. All right, we got to mark 2 more and cut them as well. Okay, so we have 2 of them now cut to length. Again, they're 19 and a half, right? Because we needed 19 inches from hole to hole. And then we've got about a 1/4 inch from the center of the hole to each edge of the part. And we've got to do the same thing again on our other, set. So we have 4 total, 1 for each side of the robot. One of the things when we mark this side now, we have to make sure this is the factory edge. I don't want to mess with that side. So it's the other side that we're going to mark from. And again, we can measure in from that side. We're looking for 19 and a half. And that's going to be roughly where we want it to be. So for me on this one, 19 and a half goes just a little bit past where I would want to be. And I know I want to be in between those 2 holes. So this is the last hole we're going to use, right? The first hole now is here. So make sure that hole to hole we have 19. This is my 19 inches to this hole. So basically we're just going to cut again right in between those 2 holes, as centered as we can. That's probably right around here. And again, as long as you got enough, that wasn't quite right, but you can adjust it. This doesn't have to be super precise as long as, again, you leave some meat around that hole. Again, if we want to do it the precise way, we can measure in to find our 19-inch hole to hole spot, which is right here. And then that means we want to cut somewhere in between that hole and the next hole. And again, we can go to like 1/4 inch or so on the calipers. And 1/4 inch is too far. This one is 0.15, right? It's, let's measure in between, it's 0.31. So sure, 0.15 something, close enough. So again, that mark is what we're aiming for. But again, just eyeballing in between the 2 holes is probably going to be enough. So right about there. Really quick, just because I don't want to waste any material, if I line these up, my holes are in the same place. And if I take the ones we already cut and line those up, we are also in the right spot. So sanity check. All right, let's go cut these. Okay, same thing, 2 more cuts. All right, let's get these filed. All right, let's just file off the burrs here and get them ready for assembly. All right, cut, filed, we're ready to assemble. So we can do this, let's pick one module. We'll work off of one module here. And essentially we're gonna have one of these going out either direction from this. So we'll have our corner of our robot here. And again, it's those 2.5-inch long bolts. Just line the holes up as best you can. And it will, the bolts will help align it too, but if you get it lined up nicely to start with, they drop in pretty easily to get started. And if you look on the bottom here, there's actually room for 5 bolts, but 2 of them, if you drop a bolt in, it actually goes all the way down inside the bottom piece and doesn't actually clamp on the bottom at all. So you can run extra bolts there. I think the instructions say you can run slightly shorter ones, 2.25-inch bolts on the 2 inside holes. But the middle hole and the 2 outside holes, you want to use the 2.5-inch bolts. And honestly, I think just those 3 bolts are probably going to be enough for us. But we should Loctite those in. So we'll add some drops of Loctite on here. And it just depends on your robot, how your robot is built specifically. You might end up using those extra holes to attach something else that sits lower on the frame of your robot here. Or if you just want to get extra careful, you can, obviously you can have 5 bolts instead of 3. All right, and the last one. Sometimes you got to wiggle the bolt a bit too to make sure it lines up with the lower hole as well. All right, let's see. I think we can tighten these down. We may regret that and may have to come back and loosen them up a little bit if we can't get the other corners to line up. All right, let's do this one. Make sure you're lining up the last hole on the aluminum piece with the last hole on our Swerve module here. Oh yeah, and Loctite. There it goes. We'll mention too with these ones, because they're button heads, the Allen wrench doesn't have quite as much room to go into them as socket head bolts. So it's not so bad when we're tightening it down, but remember when you loosen these, if you ever have to take it apart, the Loctite is going to be an extra force that's helping to hold everything together. So make sure your Allen wrench is all the way in when you go to loosen these. If it's only in part way, there is a chance that you can start stripping the bolt and then It's just a little bit easier to do with button heads than socket heads. All right, this corner is done. I guess let's flip another module over here, and we'll just continue. We'll line this one up on this side. Remember, be careful with the wires as we go through this process. But I do find it sits pretty nicely on the ends of the motors, and I think it's resting sometimes on the encoder housing. So you definitely want to be careful when it's sitting in this upside down position. We don't want to damage any of those things that are there, but if you're gentle, it's not going to hurt anything. All right, and we got 3 more bolts to go. And we'll snug them down. Okay. And we just throw another one on the other side here. There we go. Snug those down, and now we can kind of line up everything else just to make sure it's going to fit here. Looks close enough. So what might have happened is there's some play in these, so I could probably force these in and out just a little bit. And that'll probably happen when we go to attach the last set of stuff here. Looks like I'm short a few bolts, so let me grab another set. And same thing, 4 more times. All right, last corner. I got some 2 1/4 bolts mixed in. Make sure I get the 2 1/2s. All right, so this is the one where you might have to pull on it a bit to get everything to line up, and that's okay. Or if you can't, you'll have to go back and loosen up some of the other bolts. This one looks like it's close, but it should go. Okay. We can flip it over for a second again. Don't pinch any wires when you're doing this. And we're just going to check to make sure everything ended up the way we wanted it to end up before we move on to the next step. So we can see basically all 4 of the modules are doing a nice job of sitting on the ground. Everything is relatively level. Let's check if we got our size right. Remember, I wanted 28 by 28, and this is pretty much exactly 28 by 28. So perfect. Our numbers were right. Everything worked out. Next step that we're going to add here is the belly pan. So there are lots of different options for belly pans. What we're going to use is just a piece of wood. So this is like birch, I think Baltic birch plywood, 6 millimeters thick or 1/4 inch. Just be careful if you're trying to buy exactly the same thing at the like Home Depot and stuff like that. A lot of times their wood is thinner, a lot thinner than the number. So if you buy 1/4 inch plywood, but it's actually like 0.2, you might be a little thin. Also, lots of teams use polycarbonate or aluminum for the belly pan. But this was easy. If you really want to make exactly this model, we can link a drawing for it and a DXF file if you want to go ahead and laser cut or CNC your own. But go ahead and flip your robot back over. And we can talk about what our goals with this is by attaching a piece that connects all the sides together, we're going to add some more strength to the whole thing. That's going to help us out. Also, it's going to give us a nice surface to attach our electronics and battery and stuff like that too. The shape can be almost anything. Like, for example, I have these weird cutouts here going around the modules. The idea for that was so I should be able to take the caps off and be able to add or remove wires without having to take the whole bottom off. So maybe I would have wanted to even cut a little bit more space there. But if you had to just cut this straight off, that would be fine. You would lose a little bit of width in terms of how you're attaching it, but it would still work no problem. So our goal is going to be to go ahead and we'll rivet this in place. So let me grab the riveter and the rivets. All right, so now we're just going to rivet the belly pan on. Just make sure your rivets are long enough to get through all of the material and that there's a little bit of material left on the other side to crush down. Various sizes of things. If you use polycarb, it can probably be thinner. If you use aluminum, it can definitely be thinner. The one thing with wood is sometimes riveting, as long as the rivet head, the flat part is against the wood, usually it works out, but we do have some washers, so if it looks like you're worried about that, you can drop a washer in there, and that will help hold it in place. I'll use the washer just to spread the forces out, help protect the wood a little bit. We'll try the next one. I'm going to jump all the way to the ends here. I'm going to do all the corners first, and then I'll fill some more in the middle. So let's see what happens if I don't use a washer on this one. Yeah, that looks fine. So kind of up to you. Probably safer if you use a washer, but it's going to be OK either way. All right, let's get 2 across the back here. And then over to this side. 2 more over here. And some of these don't line up perfectly. That might be because when I bolted it, things were on a tiny angle. That might also just be because my file that I laser cut was not perfect. But it's close enough, I think, that I should be able to get it to go. All right, 2 more on this side. Huh. Why doesn't that one go? Yeah. Let's try this side first. And that last hole looks a little bit off. There we go. Okay. Now that we have those in, it's pretty secure, but if I push on it, the middle moves a little bit. So I think we'll do maybe 2 more spread out evenly. So 3, 6, 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right, so like here and here. And let's see, wood's chipped a little bit on this one, so I'll use a washer. Okay, 2 more on the other sides as well. 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And the last side, 3, 4, 5, 6, 7. All right, let's see. This feels pretty secure. If I push at the corners, it's not really lifting up at all. And we're lined up with the bottom of the robot, so let's go ahead and flip it over. And yeah, that looks good. All right, next step, let's find a place to mount the battery. Okay, obviously for your robot, you're gonna have requirements for where the battery can and can't be based on other mechanisms and stuff that you're building. If you're just doing a test chassis like this, I don't know, I was just trying to come up with an easy way to attach the battery using more or less the materials that I have left to me. So somewhere like here seems like a good position for it. We've got the extra cutoffs. So this is what was left after we made our side rails. And the factory side will line up nicely on the edge here. And I do have some of these angle brackets that I think I can use to attach those in place. And that's gonna be, it looks like just a little bit wider than the battery should be, but I can put something inside here to deal with that extra gap that we're gonna have. So I think I'll start by riveting this on, and then I will eventually just take another piece of angle that'll go in between here, and we'll rivet that down as well, so then the battery can't move anywhere, and then maybe drill some holes so I can run a Velcro strap over the top. So let's start by riveting these ones in. Looks like we're gonna be 2 holes from one edge, or from one Swerve module, and 1 hole on the other side. And let's see, I think I can grab some shorter rivets for this too, since we don't have to go through quite as much stuff. These seem good. And I think this bracket was made custom, was homemade. But you know, all the companies sell T-brackets, angle brackets, and stuff like that I think works on the same hole spacing. So you can buy this if you prefer. All right, pretty good. Let's do the other side here. Okay, that looks good. Let's move the battery out of the way. These I think are pretty good tipping in and out, but they can flex up and down a lot. So I do kind of want to rivet them to the wood as well. So I think to do that, I can drill down from the top, and that will line the holes up with the box that is here. Guess if you were using polycarb or something, you could probably just look and line up the holes. But I'll do the second hole here. Make sure I'm in the hole, yep. And we'll go through. And then same thing on this side. And then, yeah, let's do the end one. And somewhere in the middle. Okay, so then I should be able to, let's see, I guess we're gonna flip this over. Maybe tip it up. Just make sure I don't crush any wires. Yeah, it's pretty stable. Okay, and then back to the longer rivets, because we're going through the thicker wood piece. Get that in. Not super cleanest of holes, but still feels like it's okay. Again, if it looks like it's chipping a little bit more, you can throw one of those washers on. All right, let's tip that back down. Oh yeah, that's super sturdy. Liking that. Okay. Let's see if this angle piece is short enough to fit in between. Perfect. And I think what I want to do too is I want to add a little bit of space between them. And I usually do that. You could stick a folded up piece of paper in there. In this case, I think maybe I'll just kind of wedge the bag in there or something. But I find that the batteries will vary in size a little bit, so don't go too tight. But let me pre-drill some holes in this piece of angle here. So we'll get that clamped on maybe on the end of the table. And I guess you could measure and mark if you really wanted to be precise, but it doesn't really matter where these holes ends up. Let's go ahead and do 3. Okay, that looks good. Let me go ahead and file these holes off, and then we'll come back and get this attached to the robot. All right, so we got our piece with some holes. They are cleaned up a bit. I'm going to use this, like I said, this plastic bag just to get a little bit of spacing here, so I'm not right up against the battery. And really, I'm just going to kind of hold this and we'll drill through the wood. Be careful not to keep going through the table. And then let's do the other end. Okay. And I'll do the middle one after we start attaching it so I'm not near the battery wires. Okay. For this, I definitely want to rivet up from the bottom because, again, the ball side of the rivet will sort of crush into the wood, and that's not going to work as well. So let's go ahead and do another tip it up on its side. Watching out for the wires. So there's one. There's 2. All right, let's go ahead and rivet these in. Okay, and then I'm just going to trace through that last hole. Throw one more rivet on the middle. Okay, looks good. Let's see how the battery goes. Yeah, okay. So we got to handle this side to side, but the front to back is really good. I will mention too, we should check, I think we didn't check after we bolted the sides of the frame on and put the belly pan. Let me flip this back up. If you remember, we had to trim some of these side pieces just to make sure the wheels didn't hit. So you should do a full, we're already picking up all the hair, do a full 360 on all of your wheels just to make sure that they aren't hitting anything. And you can kind of look in that corner and make sure it clears okay. Mine are definitely good, not even close. All right, so now back to the battery problem, which is the battery is good forward and backwards on the robot, but has too much room to move left and right, shall we say. I guess right now we don't really have a front. Let's say the battery is the front from now on. So I have to put something on the sides here just to take up that space. Obviously, you can have plastic or wood or rubber or whatever you want to put in there. Something that I found that works pretty well for this is some of those furniture, like the felt things on the bottom, because they're pretty stiff, but they're also nice and soft, so they'll hold onto the battery well, and they stick pretty good. So I'm just going to go ahead and throw a couple of those on each side here. So if I put 2 on this side, let me drop the battery in now, and let's see. So that still moves a lot. But if I slide some on the other side, that's pretty close actually. So yeah, let's go ahead and put some on the other side as well. And then let's see where we are. Okay, that's pretty good. There's a little bit of movement, but not too much. So I think that's gonna work. Last thing is, got a Velcro strap. And if I go across the battery, I guess I can go my choice of directions, but then that strap will help hold it down in place and also keep it from shifting. So what I need to do for this is I need to put some holes on the sides here where I can run the Velcro strap around these metal pieces. So let's grab a big drill bit. Let's go with 1/2 inch, that seems fine. And we'll also probably want to drill this one off the edge of the table so I don't accidentally drill into the table. All right. The wheels are all pointing different directions, so it's kind of, let's do it this way. Yeah, that seems good. All right, so just throw a quick hole here. One on the other side. And I think if I do one more hole right next to it, that will also help. All right. That looks good. I probably should have left it off the edge of the table. All right, so what we need to do is pass one end up through this side. One end up through this side. And we can pull that tight. All right, that's looking good. Okay, so our battery is attached. And I think we are completely done with the mechanical build of this robot. So next step, in the next video, we'll come back, we'll bring all of the electronics components and get all of these wires hooked up to something. But that's it for this video. So before we go, we're gonna give another special thanks to Argosy for making this all possible, and to our product sponsors, Cross the Road Electronics and West Coast Products. And of course, another thank you to Team 302 and Lake Orion High School for hosting us.